Global Health Solutions present HeartQuest HRV as a functional assessment tools for research and education purpose only. Today's topic, we will be cover up the brain activity. So on the HeartQuest HRV system, we have a few parameters which we will go through so one of them is basically the brain power. So this is what with the parameters, the first parameter is showing up, and so how to interpret this parameter. So they basically on the eye icon over here, when you click eye icon and see the numbers, so you see what's the corresponding percentage information, and will tell us information about what's the brain activity. When the number is very low on this kind of like stuff over here from 0 to 17 or 17 to 33, so it will tell us information about the central nervous system is under stress or some depression. So we would like to see our client in this zone from the 50 to the up to the 100. Next parameter is what we're looking for. It's brain toxicity. So the brain toxicity range is running from the negative 1.5 to the positive 6.0. In this case, so the more positive, it's better. So it has less brain toxicity. So the research has indicated what's the brain toxicity parameter starting from 0.5 and lower, correlating with a clinical presentation of early brain intoxication. So the range is ideal range, so we would like to see it's between 4 and 6 positive. The good one still kind of like from 2 positive to the 4 positive. So fair, it's from 2 positive to the 0.5, and then when it's lower than positive 0.5 and lower, so it's kind of like showing up, so there's some brain intoxication. So this why, so it's like a color over here, so it's showing up the green, yellow, or red. Well, kind of like color presenting, so if it's good condition or less condition. Next parameter, what we're looking for, it's a brain neurotransmitter ratio. So we're not directly measuring the brain neurotransmitters. So this information was extracted from the frequency spectrum, and so we would like to see how this brain neurotransmitters frequency is correlating to each other. So we have showing up over here, so the excitatory neurotransmitters, dopamine, norepi, and inhibitory neurotransmitter, acetylcholine, GABA, and serotonin. Ideally, so we would like to see all neurotransmitter kind of like in the green zone, green corridor, but in this case, so we can see some of them is running high, some of them is running low. So let's see one of the examples. So over here, so when the brain activity is very low and the brain intoxication is very high, we see it's a lot of brain neurotransmitters shifted to the blue zone, which is kind of like telling us information what's the old brain neurotransmitters is running low. This is what the kind of what we see, it's in the normal. So the brain activity is high, brain intoxication is very low, and the old brain neurotransmitter is kind of trying to stay in the green zone, in the green corridor. So they kind of looking more correlation and a ratio between old excitatory and inhibitory neurotransmitters. We have a lot of question about why we all the time see it's norepi is running low. Just because the dopamine and is a precursor of norepi and epi, and during the stress, so basically the transition, the chemical reaction is kind of shifted more into the epi, and this why so it's producing less norepi. In this case, we see the dopamine is shifted more into the production of the epinephrine, and this is eventually producing less norepi. And if the stress is still continues, so they will depleting the dopamine production. Next one icon, so we want to see what's the brain electrical activity. Again, so we not directly will record electrical activity of the brain. It's extracted from the heart rate, so it's a brain-heart communication, and we want to see how the total power total brain electrical activities. Ideally, we would like to stay when we awake in the alpha and the beta stage. So this is kind of like showing up the corridor where it will be the normal corridor for this one. Sometimes when we see it's shifted more to the high beta or gamma, so it's all producing more anxiety stage. So it's a higher frequency, more anxiety. And then when it shifted more to the delta wave, to the slowdown, so this is what we see during the stress situation, and some depression, or when the brain is kind of like trying to put on a slow mode, and then so this why so we see so the delta wave is running very high. So this is the coverage for the brain activity, brain neurotransmitters, and brain toxicity.